participant. See if there's any attendee.
No.
Yeah, one. Take a look. No.
Yes, the number's climbing.
Yes, these are the attendees are in the room. Okay, Professor Brayne is in the room.
Very good.
I have upgraded her to panelist.
Okay, good.
Hi, Professor Brayne, is it okay right now?
I think so, yes, and I can get on to share screen as well, yes.
Oh, good.
Amazing.
Great.
That's
Finally.
very good news. Okay.
Shall we just test it out?
Yeah.
Are you able to share the screen?
Yeah, I will just get the first slide up. And
If you can see that green button,
Yes.
that should be fine.
That's fine.
now, wait a minute. Just got to, here we go. Make sure it's on the right screen because I've got two screens, of course. Here we go. Can you see the slide?
Yes.
Perfect,
Good.
perfect.
Perfect.
We can move this to the edge. Yeah. Good.
Yeah.
Yeah. Looks good.
Looks good. Yes.
Good, good, good.
Thank you for your help. And I think I'll formally open the session now.
Maybe, yeah. Just it's recording right now.
Yeah.
It's okay.
Thank you so much to our wonderful technical team, Murphy and Teresa in Hong Kong and Adam in Shenzhen. This is truly a global event with all of the operations side handled in Hong Kong, or the Greater Bay Area, I should more precisely say, and attendees from all over the world. Our guest speaker, our opening speaker, our keynote, Professor Brayne in Cambridge, and myself in Goodge Street, London. Well, thank you so much for attending, for registering, and for spreading the word about this event. We're very delighted to open the session today. This is something that we've worked towards for several years, really. And I'm really pleased that Professor Brayne has agreed to be our opening speaker. The first reason I'm pleased is because Professor Brayne is, of course, the world's leading expert on public health concerns in the field of aging and dementia. The profile of Professor Brayne really speaks for itself, and I don't need to rehearse it, but I will just mention a couple of key points. The first is Professor Brayne is probably, well, certainly amongst the top 10 women in terms of citation and impact in the world. So it's truly an honor to have such a person of high caliber speaking at our meeting, but also gives me the opportunity to congratulate and recognize the work that Professor Brayne has done and the achievements of her work in raising the profile of dementia and public health and epidemiology globally. And for that, I'm truly grateful. The second point I wish to make, it's not obvious from Professor Brayne's biography, although I would point out that Professor Brayne has herself worked at Cambridge for many, many years and has achieved a great deal of accomplishments through her work in the UK, in Cambridge, and of course, abroad. But what's not known, I think, is that Professor Brayne has a history of family experience in Hong Kong, dating back for several years, and she may like to share that with us briefly. And as a way of introducing this opening session to you as a focus on the Greater Bay Area, I'll just describe how Hong Kong, together with Guangdong, Macau, and other parts of the Southern China Bay Area, are all involved in working towards policy, prevention, and intervention in dementia. And this is why I think Professor Brayne is the ideal candidate to speak this morning. Finally, Professor Brayne and I share a great deal of experience at Hughes Hall in Cambridge. I was a visiting fellow on several occasions in the past 10 years, and Professor Brayne is still currently a fellow at Hughes Hall. And we met last year, or perhaps it was the year before, on a day just before the lockdown, so it must have been last year, to discuss aging, dementia, and to show how Hughes Hall is building a bridge between basic research at Cambridge and the impact of that research in the global community. So without further ado, I shall ask Professor Brayne to share her slides and to begin her presentation this morning in UK and this afternoon in Hong Kong. Thank you. Go ahead, Carol.
Thanks so much for such a fulsome and somewhat embarrassing introduction, I feel. Thank you so much. I'm really honoured to be the opening speaker for this conference, where you've got such a fabulous lineup coming when the conference gets underway proper. So I'm very grateful to you for setting aside the time now, sort of in advance of the opening of the main bulk of the main set of talks, to give you this kind of broad introduction, I suppose, to the field of epidemiology and population research in dementia, and share with you my experiences. But before I do start that, I probably ought to just simply fill in the gaps on Brenda's kind mentioning of the family. So my just to say, my great uncle was Lugard, who was involved in the foundation of Hong Kong University and was governor of Hong Kong, and he very much heavily influenced my grandfather, who was a colonial civil servant in India. And he actually, although he wasn't anything to do with public health, he was very keen on aspects such as education of women, mosquito nets, eradication of mosquitoes. And we're talking about the early 20th century here, and trying to encourage changes in practice so that there was less deforestation, for example. All these things have not gone away and are really important in terms of public health now. And of course, they were both absolutely exemplars of the British colonial system, including acquisition of territories. Of course, the history is a very, very, very interesting in terms of being very mixed, in that I think we now, with the benefit of history and time, are at a period of history or a period of time when we want to both recognize the really bad things that happened and the appalling aspects of any kind of invasion and colonial approaches to nations, but also reflect on what is positive about what may be the history that we can be proud of, and also that we recognize wasn't good and has led to cross-generational distress, shall we say, and try to live together. I have nephews and nieces who are in fact embodiment of both histories, being slave and being descendants of slave history, but also being descendants of my own family. So my own biological family, as it were. So we all embody this very complicated history that we have. And of course, in Asia, the history across centuries is also extremely complicated, and I'm very aware of that. And I think that historians have a great part to play in societal development and also in public health. In fact, I think we ignore history at our peril. And I make a plea for all the disciplines, not just the economists, but also social scientists, anthropologists, lawyers, and so on. In the field of public health, it's really important that we engage all these disciplines so that we have a full understanding of how to improve health for the whole and well-being for the whole population. So that's by way of a bit of a preamble to my talk, stimulated by Brendan's kind introduction. So I'll start the main talk now, and I've got quite a lot of slides because I was invited to speak for quite a long time. So I hope you'll stay with me through this journey. This is a talk that I have, the kind of main bulk of it I have given a few times, but I have tailored it obviously to you as an audience. So some of you may have heard parts of it before, but I hope there'll be bits which will be of interest despite that, or the refreshment will be of value. So I've been doing population-based studies for quite some time, and now my screen is not responding to the next. Let me just try to, yeah, great, excellent. Sorry about that. Yeah, okay, so I've been doing research since the mid-80s, and I'm sure many of the audience will not have been born at that time. And so what I bring now to the field is a sense of context and time. Because I've been studying and alongside multidisciplinary teams which are distributed across the UK and collaborating with people across the world, studying populations for that period. So you see a lot of change across time. And I'm putting this up really because I know that you've got this very great interest in working in locality, as it were, although it's a very big locality around you, on prevention and enhancement of brain health. And so I thought I would show this slide first to reflect that aspiration that you have collectively, and that's terrific. Just to show why we can't expect populations to be the same, why we can't expect older populations to look the same across time and across countries and across generations. And this gives you the life expectancy at particular years. And as you'll know, many of you in the audience will know, life expectancy is a sort of fictional thing. It's a thing that you can create in a single year using all the mortality statistics from that year and for individual groups within that. So you can look at, if you were to live your whole life in this year, how long would you live? And so it's a kind of a collapsing of all the mortality rates for a given year. And so it doesn't reflect our life courses, because of course we experience the force of mortality across our life courses, and at a certain point we succumb. But it does reflect a country's or a locality's or a group's life expectancy instantaneously. So what you can see here is an exercise that Yutu Wu did, she's now in Newcastle, but she was a PhD student with me at the time. And what you can see here is the very dramatic impact of different events, different international and regional events across the globe on life expectancy at particular times, and that they are different. And that although in general the life expectancy trajectory has gone up, there have been perturbations. And those perturbations will influence the different age groups in different ways. So if you're experiencing these very dramatic drops in life expectancy during your lifetime, you might experience them as a pregnant mother, as a newborn baby, as a child, adolescent, midlife, late life. And of course, they're likely to influence your life course trajectory of aging quite substantially, because there are major kind of contextual changes in whether you've got food, what your social engagement is, what the opportunities for education are, and so on. And I hope during my talk I can sort of show you these things and how we look at them in populations across time, across life courses. But we can only necessarily look at individual cohorts. When we're doing the sorts of work that I've done, you start off with a population cohort, and then you're locked into that cohort in that country, in that place. And I think we must remember that it is only that generation in that place at that time and in that life stage at that time. And bear in mind these bigger picture things that are occurring all around us all the time. So you'll all be familiar with this kind of slide, which is about the dramatic increase of life expectancy and the impact on the profile of age groups for both men and women. and what is anticipated. Now, this is actually a little out of date because it doesn't include what will be a perturbation related to global COVID, because that has had an impact on mortality rates. But it will be a kind of a transient thing, I suspect, and will restabilize perhaps at a different level. But what you can see most importantly here is the rise in the proportion of the population that will be in the old age groups. And at the time that I started out in epidemiological research, there were really very few epidemiological studies around the world. It was rare for them to be population-based, and governments around the world, most particularly in high-income countries at that time, were just becoming aware that they needed to pay attention to the aging population. And so people started to talk in those days about sort of pensions, so in our context in the UK, about pensions and work into later life and so on. So it's, although we are facing sort of the challenges of aging populations now, and decisions have still not been made, it's not for lack of being aware that this is an issue in global society. I, at that time, looked at the literature on dementia. Basically, I could, at that time in the 80s, you couldn't do this now, but by hand and using Index Medicus that the older amongst you might just remember. I searched the entire literature doing kind of what might be now called snowball methods on dementia, and everything that I could lay my hands on, whether it was animal research, whether it was biological research, whether it was mathematical research, and so on. And what I can say is that pretty well everything that I read in those days, I read thousands of papers and so on for my MD, all the concepts were there then, but what's happened over the decades is that we've become much more refined. We've got much better methods at looking in depth at the individual hypotheses and the concepts that were being suggested then. In the mid-80s, we also had the development of the criteria for dementia, which was seen as the most important kind of aspect of aging if we're thinking about the health in the populations, because it was already recognized that cognitive decline and disability were major issues that we would be facing with aging societies. But we were able to, I was able to kind of get my hands around the literature and really understand what was happening. But the knowledge that gave me, the reading of the literature before I started my study, led me to think that, or develop the population approach that basically I've pursued through my whole career. So building on that literature, I designed a study which I'll describe in a moment. But what was obvious from these projections is that we need research which is on the oldest old as well as on the younger populations. And at the time I was studying epidemiology, so I was kind of getting the more general population health and the concepts of epidemiology being very much embedded into what was then my medical knowledge. Okay, so what I realized when I was doing all that reading and thinking about the projections of the demographic projections was that we really need to examine older people in context, that we have to examine disorders and diseases in the context of contemporary populations. And that even then I was aware that dementia and cognitive change, particularly when you look at the criteria for dementia that were emerging at the time in the mid-80s, with the conceptualization or the separation out of Alzheimer's disease from aging, and the combining of senile dementia with Alzheimer's disease, that these things all occur in the context of history, community, and life course health influences. So I'll carry on with that theme throughout the whole talk. So aging in place. And so these folk on the right-hand side are 5 generations of one family, and the ladies at the bottom are participants in our studies. And clearly we've seen dramatic changes in the likelihood of multi-generational families. So we've seen incredible changes in our social structures across time because of the increasing longevity. And depending on your age at birth, of the mother, the intergenerational gaps are highly variable across different countries. And in this particular population, obviously it was quite a short intergenerational gap, allowing 5 generations to all be together. This is from a newspaper. And this is just to emphasize the populations in place. I mean, real people, we're looking at real people, not abstract concepts of a brain or an image or a set of biological markers. So I've already kind of introduced this concept of dementia syndrome being a bit movable depending on which time and period and fashion you're in. But basically, the dementia syndrome is the clinical syndrome. This is the thing that societies are worried about because it combines the cognitive decline with the impairment in daily activities. But there are all sorts of things around in terms of context and culture that influence that, including whether you value the independence of the individual beyond everything else. And of course, in high-income countries, this is incredibly important because we expect our old people to be highly functional and live on their own because the number of children is smaller and there's scattering of the families across the country and also across countries and internationally. And of course, that's a pattern that has become more dominant in the world more generally, particularly with migration. So there are all sorts of issues here about why it is that we want to define independence and dependence in different ways. But dementia gets caught up in that discussion because it's those decisions about which we make on a binary basis in dementia diagnosis, is this person impaired on this particular thing or not? That is influenced by the context in which the scales are developed and the underlying philosophy about how we perceive our aging populations. So each one of the things, and this is what I learned right at the beginning of my epidemiology training, when you look at a disorder and you go out into the population and you have a good enough measure, almost everything is dimensional, not binary, and we impose a binary on it. That is very useful for clinical practice. It's essential, in fact, for medical practice, but it's not particularly helpful necessarily in understanding the disorder in the context of the population. And it's highly subject to, as it were, fashions in terms of changing where you put that binary, yes, no, this criterion is met, this criterion is not met. And that can be very subjective. However objective we think we're being, it can be quite influenced by the contextual subjectivity, if you like. So the dimensional aspects of dementia syndrome are cognition, ability to function, and then the things that you put into the exclusion criteria, and also the understanding the sort of level of consciousness and whether it's delirium or not. And of course, delirium and dementia are closely linked. So the syndrome itself presents these challenges to definition, but we've done it, of course, over the decades, and it's become apparently more precise. But I would still argue that if you apply different sets of criteria in different populations with different clinicians or different standardized methodologies, you will identify different people as having dementia. So we just always need to bear that in mind, that it is not a definite thing, a 0-1. We treat much of dementia as though it is a 0-1. And of course, it applies particularly in the minimal and mild areas. And when you have concepts such as mild cognitive impairment, it makes it even more complex, although it does recognize to some extent that dimensional angle. So subtypes. Of course, as I mentioned in the mid-80s, when I was just looking at that huge literature that existed, but nothing like what it is now, Alzheimer's was emerging as this, people looking in the brains, and they were saying we can't distinguish between senile dementia of the Alzheimer type and Alzheimer's in younger age groups, so it was all combined. I think in retrospect, that was possibly not, well, it was almost certainly from a population perspective point of view, not that helpful. Because it meant that people forgot about aging or tried to say aging isn't important. But that's the dominant kind of language at the moment, and most people talk about Alzheimer's in the first breath when they're talking about dementia syndrome. And so the population is the public is quite confused about this. I get so many questions about, does she have dementia, or is it Alzheimer's? And of course, it's not like that. The vascular component and subtypes was always there from the outset, from the 80s and from the early dementia research, but it went right out of fashion with the dominance of Alzheimer's and the creation of the biomedical industrial juggernaut to look for drugs and for medication for Alzheimer's, because people, for the Alzheimer's pathologies, because people thought that there would be something that was tractable. So vascular went out of fashion, and it actually had an impact because when you were doing the exclusion criteria for Alzheimer's, you basically excluded people who had vascular features. So a lot of research became quite circular in terms of looking for vascular features in Alzheimer's when you'd already excluded in the clinical diagnostic process people who had vascular pathologies. And of course, it didn't recognize the mixture at all. And then Lewy body came in, and then there was the whole challenge of looking at Lewy body and Parkinson's disease. And of course, again, if you think about continua and syndromes and dimensions, it's not a problem. But for the categorization, there was an agonizing about dementia of Lewy body type and Parkinson's disease with dementia. And I think that whole world is coming, that's now recognized to be a bit more linked up. And very much more recently, we have a hippocampal sclerosis and looking at within the brain at this very particular pathology, which is a concentration of proteins within the hippocampus, which is the TDP43. And of course, a lot of these are linked to clumping of proteins, whether they be beta amyloid or tau, alpha-synuclein or TDP43. And then, of course, there's all the rest of dementia, the things which are clearly associated with severe cognitive impairment and that relate to exposures such as trauma, alcohol, infection, and most particularly HIV, and possibly the treatments for HIV. And COVID-19 is of course under intense scrutiny at the moment. So this is by way of just describing our tendency to split and the reductionist approach, but that it's a very complex field in which there is so much going on in the brain. And of course, all these things can be going on in the brain at any one time. So this is really important from a population point of view. So when I started out in the earliest part of my career, having read that literature, I was taught to examine the thing, and the evidence base suggested it wasn't binary. So there was a need to deconstruct the criteria and not go for, when I was doing population-based research, not go for a yes, no, on my clinical judgment, I think this person has got dementia. So I recognized that I at that time needed to measure all possible variables that were associated with a diagnosis of dementia and its exclusion criteria. And in the end, that means you're looking at the whole health of an individual, because you can't really do a dementia diagnosis or come to a judgment unless you have understood the person in their entirety and their medical history and their physical state and their mental health. So I then went out to describe in a whole but homogeneous population from a very specific and stable area of Cambridgeshire, just north of Cambridgeshire, all the women, aged pretty well all the women, 90% response rate, which is unheard of these days. Perhaps you might be more successful in local studies. But in the West, the response rates have plummeted, sadly. And I interviewed 365 women aged 70 to 79. And the reason why I chose that age group is partly going back to that demographic picture, which is from the literature that I read at the time, I felt that 75, 76 was the point at which we already knew that's where the inflection point was for dementia because of the doubling of prevalence every 5 years. And I thought that was the key moment to look at the change between the younger and the older women, and that you could probably extrapolate everything else from those points forward because of the stability of dementia in populations. In order to really understand what was happening in their context, I also interviewed 360s informants, and it wasn't the partners, because I felt that that was not sufficiently detached, as it were. And so that was usually children, but often friends, but people who were not part of the household. And I interviewed the women on their own because I thought that it was very important that they were interviewed in their own themselves. So this is a really interesting methodological area, which is if you interview somebody with somebody present, it has an influence on the nature of the content of the responses. And of course, you don't necessarily get that kind of information when you look at studies and in the very high level descriptions that you get in papers. I used the best instruments available at the time. Martin Roths and Felicia Huppert were working with colleagues in Cambridge on the CAMDEX, which was a standardized interview for diagnosis of mental disorders in older people, and also the geriatric mental state, which we then went on to use in the later cognitive function and aging studies. And we did some comparisons. So I persuaded my husband to do a random, who's a psychiatrist, to do a random sample of the people that I'd interviewed with the CAMDEX using the GMS. And we could see, as I mentioned, the variability between instruments in the nature of the diagnosis that came out of each instrument. And that's a finding that was then very nicely published by Erkinjunti on the Canadian Study of Health and Aging, showing that different diagnostic criteria and different application of these diagnostic criteria led to quite different identification of people being labeled as dementia. So this was effectively deep phenotyping a very long time ago. And I did a neurological exam, a cardiovascular exam, and took bloods all in the individuals, the respondents' homes. And I brought it home and I spun it in a centrifuge in our outbuildings and kept it in a freezer at home. These are all things which would not be possible now. I was quite in this, we were talking about sort of, I suppose, the Wild West of before all of much more control, much more standardized in terms of what you do now. And of course, you can do far more in terms of bloods and imaging these days. I also did the NART IQ for the first time in a population-based study, and I did simple and choice reaction times. There are some things that just don't change across time, and I see the same things being done again and again and being reported on again and again. So although sometimes it feels as though we're going round in circles, but sometimes you make a little advance and that's great, but there's a lot of replication. So in that study, I found that dementia syndrome measures are continuously distributed. Nothing was binary, effectively, when there was enough, when the measurement allowed that. And that included those for subtyping. So at the time, the Herchinsky, and it still is used, the Herchinsky scale was in use. And that vascular set of items was continuously distributed in this total population sample, which included a small proportion of people with dementia, of course, because it was basically going out to everyone, including those people who were on GP lists, who were in care settings, and also in the local psychiatric hospital, long stay hospital at the time. So it was quite clear that age and education influenced performance on cognitive tests, and that there was a challenge to standardization in approaches to diagnosis. However carefully you do it, it's just very challenging. And however well we think we're doing it, it's still pretty fuzzy. And in the 5-year follow-up, which I was able to do with Mary Muir, the informant and self-report memory problems were predictive of outcomes of dementia, along with other variables, but absolutely not at the level which was predictive enough to say, to use in individual clinical practice. So there was no item in the diagnostic, in the interviews that, or in the blood measures or any of those things that I was doing that basically said, this person with reasonable degree of certainty, sufficient to actually say to them, is going to develop dementia within that 5 years. So just to note, I attempted to follow up for autopsy with these individuals, and only one person came to post-mortem. And in that one person, she was a very interesting person. She was highly intelligent. She had the highest scores on the CAMCOG, which was the cognitive measure that was used in this study. And she had a huge, at the time that I interviewed her, she didn't die all that long after I'd interviewed her, she had a huge tumor, which was not interfering with her cognition at all. And that taught me to be very cautious about assuming a one-to-one relationship. If you see the brain and you see the findings in the brain, you cannot assume that you know what's happening in the person. And this really highlighted to me the importance of understanding lived lives as well as the biology, the underlying neurobiology. So this is just an illustration of the continuous distribution. This was published in the Lancet a long, long time ago, I think it was in the 80s. And in this, you can see that the younger population in the clear histogram, this is from an old slide. Some of you won't even know what that is. Diapositive, and the older group, you can see the distribution of cognition, of course, is lower as people age and as some develop dementia. And this is significantly, as it were, not binary distribution, the explanation for the difference in the distribution could, of course, because this is cross-sectional and you need to be very cautious about the interpretation of cross-sectional data, is it could be a generational change in education, say, with the younger generation having higher cognitive scores simply because they've had a bit more exposure to education. So you need to be very careful about the interpretation. So this could be due to age, but it could also be due to other factors which change across the different age groups. I looked at the relationship between IQ as measured by the NART IQ, and the NART IQ is an attempt to look at pre-morbid IQ by using irregular words. It's also highly associated with education, but in the English language, there are so many words, as you know, which are not said the way that they look. They're absolutely not phonetic. So you have to know how to say them. And that ability is retained into the early stages of dementia. It is a bit lost. And at the time, I brought this from I was doing this working as a junior doctor in Queen Square. NART was used completely regularly as part of the clinical workup. And I could see how useful it was. So I took it into the population to see how it worked in the population and used it to see whether we could improve the diagnostic ability of CAMCOG, the cognitive measure, the longer cognitive measure from CAMDEX, a mini mental state, which you'll all be familiar with, to identify people who had cognition which was lower than predicted by their IQ. So that was very much the motivation for measuring the IQ, but also to look at this psychometric G concept, which was at the time quite popular in the psychology literature, which was that there's a kind of common neurological integrity that manifests itself in all features of neurological outputs, including the brain. And so I looked at the interrelationship between the different cognitive measures. In fact, mini mental state is a substantial part of CAMCOG, so you'd expect those to have very high interrelationships, so 0.88, which is a Spearman rank, because these are not necessarily normally distributed. But here you can see that NART is highly associated, the IQ, the measure of premorbid IQ, as you would expect, highly associated with not just cognition, but also with simple reaction time and choice reaction time. And choice reaction time is trying to get at the more core neurological speed angles. But choice reaction time was more particularly associated with the cognitive measures. And simple reaction time and choice reaction time were pretty highly correlated as well. So these are all kind of pointing towards a more a non-brain specific approach to thinking about the health of our neurological systems and the integrity of the neurological systems. But it was very early data. Then I went on to join the Cambridge City over 75 cohort, which was initiated also in 1985. And this was a total population study. And just to correct Brendan, I'm afraid I'm not a fellow of Hughes Hall, I'm a fellow of Darwin College, but I have a very close association with Hughes Hall through the aging research pillar of Cambridge Public Health. And also this study, which was called the Hughes Hall Project for Later Life originally, because Peter Brook and Bernard Rice, an old age psychiatrist and a GP, supported Daniel O'Connor and Penny Pollitt, both of whom are from Australia, to conduct one of the biggest at the time, and still a really substantially large old population study in Cambridge City, and they were looking at services, basically service provision and its impact in Cambridge City. But to do that, and they wanted to look at early detection of dementia as well. I mean, this is ages ago, so this is really long stuff. And they wanted to look at early detection of dementia in the process of diagnosis and following people from minimal dementia through to mild dementia. And this was because we didn't know whether it was accurate or whether it would benefit individuals. This was not conveyed to the individuals unless they were already known to the system or unless they had medical needs that were clearly apparent and could be met. So Penny and Daniel did this big population study of over 2,500 people, highly population based, again, a huge response rate, 95%. And that provided a fabulous population platform to look, to do longitudinal studies. So from that, I picked it up from working with Jean Paykel and Felicia Huppert, and we did tons of things, which included prevalence of dementia, incidence of dementia, driving behaviors, falls, frailty, end-of-life work, and neuropathology, along with lots and lots of colleagues. I've listed just a few of them there, key colleagues from many different disciplines, including complex maths. You might have heard the name David Spiegelhalter if you follow the BBC at all, but he did some fantastic work with mathematical stuff on modeling analytical approaches to cognitive measures across time, where you have missing data and so on. David Clayton is also a superb, globally recognized biostatistician. So we were very fortunate to have this extraordinary group. And that study, so I've already described it a bit, but it's clearly over 75. We used the CAMDEX, and it effectively was screening for dementia, but looked at everything else as well in the same way that we did in my East Cambridgeshire survey. And since then, we've had repeated surveys, and we've followed the respondents right up to death. All of them have now died, and we had a brain donation program from 1988 with more than 240 brains collected. And some of the studies, some of the results that came out of that, I'm going to skate through these now, are well known. This is kind of the base from which a lot of the dementia work around the world has come. Bert Hoffman got the population-based studies of which were robust together in the EU Eurodem program. And you can see there were quite a few. And some of these were very small, some were large, some were single gender like mine in Cambridgeshire, and some were in restricted age groups like the Cambridge City over 75 cohort. But together they provided these very powerful estimates for the prevalence of dementia, which this is the same data in both of these figures. The raw data here are cases per 100, so percentage, this is a prevalence percentage and age from the different sites. And this is the logarithmic scale showing this incredibly closely associated relationship with age. I mean, it's just so powerful. And so when we see the mantra, when I see the mantra of dementia is not an inevitable consequence of aging, I think, okay, yes, not everybody dies with dementia, but it doesn't really recognize those statements lead the population to believe it's completely different from aging. And however, it occurs so much more commonly in the context of aging that it is really, really important that we don't ignore aging in research. And for many decades, we ignored dementia, ignored aging or controlled it out in research. And I could say the same thing about gender, the importance of gender as well, because that's often controlled out rather than presenting the findings for both genders, even if they are similar. So, and I'm doing it here, in fact. So one of the motivations for becoming involved in the Cambridge City over 75 cohort and taking it on when Daniel and Penny went back to Australia was the being able to look at longitudinal change in cognition. And this shows very early results which show you the distribution of change. And what you can see is there are some people who improve, and there are some people who decline on the mini-mental state in a 2-year follow-up. of over 2,000 of these individuals. We had pretty good response rates at follow-up. And what you can see here is that the mode here is at 0, but in fact, the majority or the average decline, because of this, the way that it's distributed here, is -1. So the entire population has shifted down in the time, with some people having higher mini mental states, as you'd expect, a normal distribution, a lovely normal distribution, but shifted to it slightly to decline in the population over a 2-year period. And a lot of our research has really continued to confirm that declining cognition is what we can expect as we age. And of course, it's variable across different cognitive functions, but to say that it doesn't happen is not actually reflecting what's happening in the population. So another thing that we did was the brain donation program, and that was one of our marvelous and wonderful donors, where we did a portrait. We had a project from the funding from the Wellcome Trust to do an art project. So we made our selected donors, who were very happy to do this along with their families, visible in public, and they absolutely loved it, and we loved it. It was a fantastic exercise to basically make, so who are these wonderful people who become brain donors, and it was kind of making that real for in public, and it was very well received. But one of the things that we were able to do in the brain donation program was move away from case control approaches, which are dominant in the clinical fields. And what we were able to do was to kind of just do a stock take on why is it that why is it that the clinical literature was saying you can separate people with Alzheimer's or dementia from people without dementia? They're binary. It's binary. You can pull them out and separate them. And why is it that the world of clinical research and tertiary care, tertiary setting research is so different from population, or could be so different from population research? So we kind of artificially reconstructed what a case control might look like from the brain donations. Once we had 100 brain donations in these very old people. So these are people in their 80s who are dying. And here you can see the classical Alzheimer type pathology, neurofibrillary tangles, neuritic plaques and amyloid plaques. And here, what we've done is pulled out the people who had moderate and severe dementia, and people who were kind of had no decline, no indication of decline at all. And what you can see is that you do see a kind of separation, so that if you have a case control methodology, and this is still happening, I still see it with the biomarker world. If you have this pre-selection of people, so that you're filtering them at each stage, that you're likely to then only represent certain parts of the spectrum of the dimensions that I mentioned earlier on. And if you fill that in then and think, well, what does it look like in the real messy population where, you know, it's much more complicated, this is what you see. And here you have the people who had minimal dementia as diagnosed on the Camdex, and people who had mild dementia. And what you can see is you get this continuum. So I have not seen any evidence that persuades me that there's a binary approach, that a binary approach will work. This is really important in the contemporary world because of the focus and the attention to early diagnosis. And here I present the findings from larger numbers. This is over 200 of the brains for the Braque staging, for plaque types of amyloid staging, amyloid in vessels and vascular. So these are key features that people look at, that the neuropathologists look at. And I should say our neuropathology is all done blind to age and clinical status. So the neuropathologists don't know anything about the person, because again, you get biases introduced looking for the pathology that might have created the clinical manifestation. We see it in radiology, we see it in imaging, we see it in anything like that. There's a kind of post hoc attempt to explain what's happening. So what you can see here is whether people have got these pathologies at death and whether or not they had dementia at death. And the light grey is people who do not die with dementia, and the dark grey is people who do die with dementia in the CC75C study. And what you can see, I hope, is that although there is a stronger association with these pathologies in those who have dementia at death, that there is huge, huge overlap. That is the key message I want you to take from these slides. And so if we're going to go down a biomarker route or an imaging route, if you were to have imaging for your brain, for changes in the brain or whatever, you know, as a predictor of dementia or proteins in your blood or whatever, we are going to pick up a vast number of people who would not otherwise have developed dementia later. So we have to think about the potential harms that we're doing with early detection. It's really, really important. So now I'm going to move on to the cognitive function and aging studies. And Brendan, I hope you'll stop me when you think I've been rambling on for long enough. And this is a population-based, multi-site, multi-institutional study with over 18,000 people at baseline, people aged 65 plus. The methods are really very much experiential learning brought through from not just our group in Cambridge, but also from Newcastle, and colleagues around the country and people like such as Muir Gray, sort of giants in their fields. It started in 1989, and we also added in 2010 a new generation study in Ely, Nottingham and Newcastle. So I'm going to go through some of the results from that study. So I think I've kind of laid the ground with why CFAS looks as it does, because it's all that history that sort of led into the design and the implementation. As I say, we used the geriatric mental state as a diagnosis, which to begin with, I had been using Camdex, so I actually would have preferred to use Camdex. And our instrument does have a lot of Camdex features in it because we merged the two interview types. But we used the GMS algorithmic diagnosis because that had been validated by John Copeland in Liverpool and was being used in his part of the CFAS study. And in time, I became much more comfortable with the algorithm because I could see that it actually, although it was not my preferred original approach to diagnosis, I could see that actually it provided a standardization, even though of course it's got its own foibles, as have all diagnostic approaches. But it allowed us to do a comparison across time. So this slide embodies 35 years of research because it's hundreds of thousands of interviews, and it is the cross-diagnostic, the cross-generational findings from CFAS-1 in 3 sites and CFAS-2 in 3 sites. So CFAS-1 is a subset of the original CFAS 6 sites. And what you can see here in this study, in this set of findings, is that we've compared the prevalence of dementia in the early 1990s in CFAS-1, that's the blue in the figure to the fore, with the prevalence of dementia as diagnosed by GMS algorithm in the 2010 generation. So this is a 20+ year difference in the same localities using as similar methods as we possibly could, with a difference of response rates, which I can talk about, but we corrected and tested for whether those had an impact or not. We could not break the findings. And you can see that the second generation dementia is considerably lower age for age. It didn't mean that the numbers estimated to have dementia in the UK are different, because life expectancy had increased so much. So the numbers estimated to have dementia using the red bars, which is what's in use now in policy in the UK, are the same as the numbers that were estimated in the earlier era, because so much of the population now is in those older age groups. And we found the same drop of 20% in the incidence, driven by a 40% drop in men. And this, of course, is extremely important because there is gender variation in dementia. We looked at risk, and I show this to highlight the powerful effect of age, which we tend to, as I say, I think wrongly brush aside. It's so that if you're a 65 to, or if you're a 90+-year-old, you are 25 times more likely to develop dementia than a 65 to 69-year-old. These are longitudinal data. And you're more likely if you're a woman, you're less likely if you've got high education, you're more likely if you've got poor self-reported health, you're more likely if you've got stroke, you're much more likely if you've got Parkinson's disease, and you're less likely if you've had a GA, but that's probably associated with the types of anesthesia that we were doing at the time for which types of people. So these are not new findings, these are the types, but the reason why I show this is because although it's a long time ago, this is the kind of data that feeds into those systematic reviews that then create what you'll hear about from Jill Livingston in the Lancet Commission. So we also had brain donation from this study, and there are lots of different types of work going on. And Stephen Wharton leads this in Sheffield, with Paul Ince having been a key member, and Margaret Osiri from Oxford. So, you know, a kind of collective of neuropathologists, and it's a very strong grouping, and there's lots of biological work on the frozen tissue as well as the fixed tissue going on. And we've contributed to the areas such as the TDP-43 hippocampal sclerosis criteria that were recently published by Peter Nelson on the basis of this kind of work. But it feeds in to what's going on in the older population, the older brains, which is relevant to the population, not assuming a diagnosis or with those kind of filters to clinical care that can drive the findings if you don't think about them carefully. This slide shows you the association of different features of dementia and age, and particular key pathologies. And what you can see here, just with two illustrated ones, it's for atrophy, the relationship, in fact, the line that you see for atrophy occurrence by age goes up for the non-demented group, and it goes up for the demented group. And if you superimpose one on the other, they are roughly parallel. So the relationship between the expression of dementia is roughly stable, irrespective of age, for atrophy, but it doesn't look like that for neuritic plaques at all. And this is a core feature of dementia. So in the oldest age groups, the age groups at which we are seeing the greatest increase in the population numbers, the importance, if you like, of classical Alzheimer type pathology seems to be lower. And this is, again, really important when you come back to the mantra of Alzheimer's disease in the population. We must eradicate it and we must detect it early. These findings do not support that approach. That approach works for younger age groups, maybe, but we need to think about how it works in populations as well. So we were able, with our brain donation, to look at the contribution of different key features to the occurrence, or the clinical occurrence, of dementia before death. And what you can see here is that age is incredibly important. It accounts for around 20% of the dementia seen. Brain weight is really important, around 20%. Alzheimer type pathology in and of itself, measured classically, not doing all the biomarker stuff, is 20%. Vascular pathology is 20%, and other pathologies is 15%. In fact, hippocampal sclerosis bumps that up a bit more. But you can see that this is a very different picture from the picture that is in the rhetoric of the scientific community and the public and politicians indeed. And what you can see here is that there are many pathologies that occur more often in people with dementia at death. And these are things like granulovascular degeneration in different parts. These are all different parts of the brain, so cortex, hippocampus, and then in the brainstem. And here you can see, irrespective of if you control for the Alzheimer type pathology, all of these estimates are above 1. So this is for different things like Hirano, gliosis. Gliosis has actually come into research much more since we did this analysis, and neuronal loss as well. And brainstem pathology is also more associated with the occurrence of dementia. These are all important because there has been a focus in particular areas with a sense that if you solve that problem, you'd eradicate dementia. And so what I'm saying is that it's really important that we look in the population for the thing, to understand really fully the thing that we think we're talking about. And this applies to protection as well. Of course, that's an area of great interest now in terms of education and life course protection from dementia. And here you can see that at every level of education here in this slide at the bottom right, in the presence of pathology, people with higher education are at lower risk of developing dementia during their lives. So there are protective factors going on in our lives as well as risk factors. So we tend to think about risk factors, but in fact the cognitive reserve and protection is really, really important. So in these studies, we've been able to contribute to the concepts and methodologies as well. I think I've given you a bit of a sense of that. And what really is important is that we can allow testing that's not influenced by the filters that operate when we recruit from health services or other settings, and not also volunteer bias, because you're going out to a whole population, you have a sense of who isn't taking part. Now, I think I'm going to skip this, finish up with a few slides. Brendan, am I okay just for a couple more minutes?
You are absolutely fine, Professor Brayne.
Okay, great, thanks. So one of the really terrific things about working with this distributed, multidisciplinary, multi-institutional collaboration is that we have people with such diverse skills. And so this is work that's come from Carol Jagger and colleagues in Newcastle. And it builds on work that Carol's been doing in bringing together different cohorts, such as it's called MODEM, and before that SIMPOP. But within CFAS, of course, because we've got this generational comparison, we can look at changes. And so you can see here, and this is the sort of thing that you'll be able to do if you kind of create a platform of population-based data, because it's so valuable just locally and can contribute to the international literature. But this is quite a complicated slide, and it shows you by advantage the life expectancy, again coming back to this life expectancy approach, total life expectancy, but also life expectancy with disability or disability free for men and women in the earlier generation study and in the later generation study. And it shows you really starkly the increase in life expectancy, but also the increase in life expectancy with and without disability, and what the gains are and whether you have gains or not. So you can see that in the more recent generation, basically the expectation of life spent with disability goes up. And it goes up a bit for men, but the proportions in absolute terms, but if you look at the proportions, it's actually, you get kind of what might look like paradoxical effects, but the proportion of life for, say, the most advantaged men is less than it was in the earlier generation. So we're seeing kind of changes in whole health and whole disability, and cognitive function is bound up in that. And for women, you can see the proportion of life spent in with disability has gone up. Particularly, this is really important in terms of the least advantage. So this allows us to disentangle our results in terms of advantage and disadvantage, and this then plays back into the life course angle. Multimorbidity is much more common in those with disadvantage, early lower education, all the things that cluster around the risk factors for dementia. So we knew when we set up CFAS2 and did that generational study that there were going to be things that had changed in the whole population and could either increase dementia prevalence or decrease it, incidence as well. And we made the argument successfully on about the 7th attempt to get the money to do the study. And that's why there's such a long period in between the first generation and the second generation. So it played into the testing the hypothesis in many ways, although it's spent a lot of time on it. But at the same time, there are other studies. Ours is designed to look across generational changes. Other studies have the ability to look across generation, but have different designs. But they were all put together by, again, Bert Hoffman with his group in Harvard, to look at changes across decades in the incidence of dementia. And here you can see that it's not just us, because there was an attempt at the beginning when we published our findings on CFAS2 to say, oh, that's just rubbish, you know. But actually it's seen now across different countries, and it's still not in the public domain. And the expectation or the sense is, although we can't explain these findings fully, that it is because we have changed our exposures across the life course from health of the parents, through pregnancy, through early life, through midlife and later life. And all the evidence base suggests that the shifts towards optimizing health and well-being, both for body and brain, have paid off in these generations who've been studied in these countries. So it's a very powerful public health message. I was going to just finish very quickly with a systematic review. This is not that up to date, but this was done by Yu-Tsu Wu, whose findings whose life expectancy slide I showed right at the beginning. But she did a very, very, very robust analysis of prevalence studies of dementia in China, Hong Kong, and Taiwan. And I thought I would just finish with some reflections on these, which is that this showed that there were quite a lot of studies in the different parts of these countries, mainland China, Hong Kong, and Taiwan, and that although the estimates are slightly, maybe a little bit lower than in the West, they are actually not that different in many ways. And for the different countries, they are slightly different, with higher rates in higher estimated prevalence proportions in northern China and central China, which is interesting, of course, because there will be very different life experiences for the populations in those areas. And she mapped it out onto to create estimated numbers, which provides sort of hotspots and those areas where there are less. But of course, these are estimated absolute numbers, which depend on the demographics of those areas, and by age and gender, showing the predominance of women. And it's really marked this male deficit there, and that's almost certainly because of life expectancy differences in early stages of frailty. And I wanted to end on the idea of the three major research thrusts that there are at the moment. So there's biomedical, that are currently focused on early detection, diagnostics, and potential treatments. And I hope I've explained why that is too narrow. We want clinical research to look at clinical mitigation at all stages, from mildest to end of life, and there isn't so much work going on that. And then there's even less investment, if you like, into the risk reduction for whole populations. And the focus of that is individualized approaches. And we really need to shift away from that individualized approaches to recognize that the empirical evidence is about population change, and that we need to make sure that we're trying to do that in our populations, and the policymakers understand the benefits of doing that, and that we're already seeing the benefits. And I'm going to stop there because I think I've had enough time, apart from to say we must integrate this with the Sustainable Development Goals, because there's no point in aging in a population where the future for the younger generations is not any good. So this is really important, and I think all research needs to reflect on how it sits within whole populations across generations and into the future. So thank you. I recognize this is the work of tens of thousands of people and dear colleagues. The views expressed are my own, but it is the work of many, many people, most particularly my colleague Fiona Matthews, and many funders, of course, as well. Thank you.
Oh, thank you. Thank you so much. What a wonderful presentation, and really, really fabulous to hear your thoughts and give us a foundation to begin our discussions in the next week or so. I would also like to say that I'm very honored to be able to say that your work has had an impact in China, and I forgot to mention that at the beginning, as well as your students and postdocs. And this is where I think we need to build upon the level of expertise that you've helped develop in Cambridge to move forward in the Greater Bay Area. Now, I'd like to open the floor for questions, and I'll do that by asking people to put their questions into the chat. Carol, I wondered if you needed a little break, perhaps a drink, of water.
I've got some water here. I think my husband's going to bring some coffee in a moment because we're all still working from home.
Of course, but you've spoken for so long, and I just worried a little about your.
I'm
your
fine.
So,
I feel more for your long-suffering audience, actually.
No. We have wonderful attendance. We're really pleased. The questions that are coming through, we're going to assemble them and we're going to relay them to you, and so you don't have to read through the chat, etc. And I'll begin with a question that I think is on the minds of many of us, and that is, what's the impact of the global pandemic on some of the issues that you touched upon? And we've discussed some of these issues, not in the COVID context, because the last time we met was prior to the pandemic, but we've discussed it in the context of the issues surrounding equity, social justice, and so forth. You gave a wonderful, well, you hosted a wonderful meeting at the Royal Society on this very topic. So maybe you could expand a bit from there on how the pandemic is going to, in your view, influence the way in which we go about assessing and also intervening with individuals who are diagnosed with dementia.
I suppose it's a work. It's a work in progress still, because COVID as a virus is clearly we've had the global impact, but it's been highly variable across the world, and so we're still only beginning to see the playing out in some areas of the world. It seems to be affecting populations somewhat differently, and that is within country and across country. So within country, I think, particularly in high-income countries, it's really laid bare the inequalities and the social justice issues that you raise. And not only that, also, but variation across populations. So it's not just being poor or being disadvantaged, it's also being from particular ethnic minorities in the UK at least, and the US, and also particular conditions, which themselves are those risk factors. I mean, all of those things are risk factors for dementia. So it wouldn't be a surprise if having COVID in any sort of form from moderate and onwards influences your brain health. What we don't know, I think, at the moment, and there's lots of research out there that has been doing imaging and animal studies and so on, and I think some of it has been a bit alarmist. I suppose what I might say is that if we can come out of COVID and trying to work better, like, so the G7 and the OECD, they're all very focused on just this question of how do we come out of COVID better, given the impact on the economy and so on. That if we can bring the learning that we have on inequalities and the health of the brain into those discussions, I feel we might have an impact on policy to say, hey folks, we've got really good evidence from on life course, and what we need to do is to think about how can we reduce inequalities at all stages and in ways which enhance brain health. And I would hope that would to some extent mitigate the negatives of COVID, and that the kind of wake-up call that in public health we've been very aware of, as you mentioned, Brendan, for a long time, that you don't have good brain health. And one of those slides that I've skipped over was about stunting across the world. If you don't have good brain development early in life, you're going to be at a disadvantage when you get to 65, 70, 80. So we just need to take this moment, and all of you listening, to get at our policymakers to say, use the evidence base, generate more evidence, yes, at all those life stages. We do need to know how to implement our knowledge, but there are some things where it's bland or obvious that we'll have better health. It'll be better aging and better health and better brain health as well. So I know that's a bit of a rambly answer, but I think we will see it in metrics, but perhaps not. It'll be a bit there, but and the global burden of disease work will, I think, and WHO work will kind of begin to estimate that probably next year, I think.
Well, that's a positive response, which I really appreciate. Typical of you, if I may say so. We have a couple of other questions here. Let's begin with a question that we have on the possibility of mild cognitive impairment. Could you please relay that question?
Was that the one about early diagnosis and misdiagnosis? Yes. Well, our own empirical data suggests that it's a highly, as you would expect, it's a bit like if you look at hypertension and you look at the trajectory of hypertension and you're measuring people's there's a kind of there's a period when it fluctuates a lot, and in some people it'll settle down, and in other people it'll go on to hypertension. And in fact, I wrote my master's thesis in epidemiology on this. And I think the empirical evidence is that in population-based studies, if they are truly population-based studies, the predictive value of MCI is poor. It is effectively poor. You know, if you think about me as an individual going with my family member to a clinic and being told that I've got MCI, and I say, well, what does that really mean for me at my age, at my level of education, my gender? And it'll not be, you've got a 70% chance of having dementia in 2 years, 3 years. We can't do it. We can't tell people that degree of precision. And so I mean, I know it's been valuable for those working in clinical settings, but in population settings, I think it's not that helpful. And even in clinical settings, I think the memory clinics that are set up that, as it were, attract in the MCI grouping have many people with other conditions on their books, like depression and or other sort of senses of concern about their memory. But it's not what a clinician would then say, well, I'm pretty certain this is an early cognitive change that is going to become dementia. So it leads to in my view, we didn't do enough research before we started the policy changes and the health services changes. We needed to do more evaluation of the implementation of the concept, because we now have many memory clinics, and I'm sure the clinicians are doing great jobs, but they're probably treating a lot of other conditions. I mean, it's more old age psychiatry services, and we have waiting lists for memory clinics now, and there's you know, people use the term worried well. That's not a good term, but the public has been very rattled by the attention to dementia and the lobbying and the public, the media, politician, interest groups have been very successful at making it very prominent. And that, I believe, is what's led to the fear rising in the population, you know, overtaking cancer and dementia. And yes, we've all got experience of dementia in our personal lives, but I do feel that we've often kind of rushed ahead with enthusiasm and with the best possible motivation, but before saying, oh, well, let's just wait and see, let's just work out, let's just do it in a measured way and really test whether this is benefiting the individuals we believe are going to be benefited, rather than harming them. And I don't think we've got that evidence base for MCI.
Thank you. Excellent.
Can I ask a question from the chat, from the audience? There is a question regarding the main difference between cross-sectional and longitudinal studies regarding early diagnosis. If you could comment on that, please.
Well, one of the problems with cross-sectional diagnosis is if you're making an inference about the relationship of a measure to the disease, you can't, and even in longitudinal studies, it's difficult because there may be other things that are associated with what you're measuring. But if you do it cross-sectionally, you have no idea what came first. So, for example, a really stark example I can give you is you would never do that for biomarkers in relation to cancer of the pancreas. Say, take a group of people who have cancer of the pancreas and do biomarkers on them, and then test it, and then do the same biomarkers on a group of people who haven't got cancer of the pancreas, and say those biomarkers are in any way causative. You just can't do it, because everything changes when you have cancer of the pancreas. So cross-sectional findings are very difficult to interpret in that way, because you need the time. And even in dementia, because of the, because it's dimensional, because you have to have decline over some time, you do need the measures, if you're assuming risk, to be kind of as far back as possible. And of course, that's a really strong challenge with things like depression, thinking about depression as a risk factor, because it's part of the prodrome as well for many people. It's clearly part of the prodrome, not unreasonably. It takes the adjustment stage is not easy, and people agitation and so on. There are quite a lot of things that happen in the early stages, and so it's ideally we would have both cross-sectional and longitudinal and cross-generational. And I think having a systematic approach to how we generate evidence would be very effective, actually. And if you can achieve that, sort of have a standing approach, and you incorporate new things as you go along, so that you can test changes across time, and you can look at cross-sectional and longitudinal, and also how the biases, what can be measured cross-sectionally and it's okay, and what can't. So I think that's again a bit of a long answer to your question, but I hope that answers.
Thank you. Have a little drink break, I think, and we will have a couple more questions if you're happy with that.
Yeah, sure.
I understand that today is a very important day because you appeared in the press and the media talking about prevention and risk factors, I notice. And one of the interesting points you made that I can't help but throw in is the fact that you're a fluent speaker of French and you read and write in French, and that you continue to use French, but the reason you're using a second language is not necessarily to prevent or preserve your brain health, but because it's enjoyable. And so I just like to stress that fact. Anyone can read about it online and what you're saying today, but it is an interesting point that education and all of those cognitive reserve factors that we now focus on, which I believe to be relevant, are simply a result of things that make us feel better, really. And I think that's an important point that's often missed in that literature. So thank you for making those points. And I would like to say that it is good to learn French if you are interested in preserving your brain health, but more interesting, I think, to appreciate the culture that goes with learning the language, not just sitting and learning French. So I'd like to pass on now to another question. Adam, would you like to ask that question for us on digital literacy?
Sure. So we have a question from the chat. The level of functionality is a key issue for the diagnosis of dementia. Could you please share your views on digital literacy and the diagnosis of dementia?
Oh, yeah. This is a really interesting question because we still use the activities of daily living and instrumental daily activities of living in our studies. And I think we've been talking about for many years the need to improve those, and that was before the digital revolution. So in terms of just simply adding in questions which are, and there are some of these types of measures around, functionality in terms of the video or the ever-changing modalities with which we engage with the world. And I can remember when I did my very first study, that one out in the Fens, people would tell me, these wonderful older women would tell me that I didn't like using the phone. So life has changed so dramatically. And in terms of the digital footprint, the digital fingerprint, or the way in which digital might be used, I think we need to be extremely cautious. I think we need to take a step back and think about lived lives and to whom we might be applying these things. So I think there is a real need to look at the instruments that we use to make diagnoses, how they land in different groups and different genders and different educational levels and different cultures, and what they mean in those cultures. So this is more sort of qualitative work, I think, in terms of trying to develop a robust approach to this. And I am extremely concerned about the sense, from understandable, again, it's all very well-meaning and enthusiastic, and sometimes with business interests, the idea that we might all want to be told, or your reaction times have gone down, or you're making more errors now. You need to go and see a physician to see whether you've got dementia. So I think that may be what the questioner is driving at, is this sort of digital pattern that might change across time. And if we apply algorithms to it, which are based on received data from routine records or whatever, I think we just need to be very, very careful about the nature of the data that go into algorithms and the nature of the populations to whom anything might be applied, and ensure that we've got very robust thinking about the social implications, the legal implications, and the need to ensure that we do things that benefit people's lives, not harm them, and what information is beneficial and what information is harmful. And this is a classic in screening, of course, which is we don't share information on patterns unless we're sure. We don't implement screening in populations unless we're sure that we can do more benefit than harm.
Thank you. I think we'll have a couple more questions, then we'll ask people to direct questions to us that we'll try to answer at some later time.
Professor,
I would like to, yes?
We have a question from another contributor to the conference. Dr. Raymond Chang is asked a question.
I'm just about to read it out, Adam, but perhaps you'd like to do it for me.
I was actually going to ask if perhaps we could ask him to direct it directly. I can give him microphone access.
Oh, well, let's try that.
Okay. So, Dr. Chang, you should be able to speak.
Yes. Yes. I'm here. Okay. How to? I already opened the camera, but I don't know where. There's a no.
It's okay, Raymond. We can hear you. Just ask your question. Thank you.
Okay. I want to follow up the question about the diagnosis and biomarker for the potential dementia, because you mentioned about healthy brain also have some kind of the atrophy or the deposits of the beta amyloid peptide, but they don't have dementia. So, but on the other hand, you know, there's some company, for example, the Contreras, they are now developing lots of blood-based biomarker, and they do work together with the MRI imagings. So what is your opinion or suggestions for having more parameters to accurately predict, or what is your opinion? What is your suggestion on this?
So I suppose I would say we need to take a step back and think, what is it we're trying to achieve through doing these things? Are we wanting to apply this to entire populations, or are we wanting to use it in selected groups? Are we wanting to use it in clinical settings? And all of those things have implications for the performance of any screening test. I mean, this is basically screening. And there's a very, very well-worn set of criteria that we should follow. And for some reason, I'm not quite sure why, the dementia world has sort of sidestepped the processes and the steps that have been followed for cancer, where we do trials to test screening, to really work out what the performance of these things is. Because the Cochrane reviews of the performance of these different measures to date has not really been that encouraging. And that takes us through the findings in great detail and says, what's the provenance of the populations being studied? What's the performance? What's the outcome? How long is the follow-up? And all those sorts of things. There's a very, very clear set of criteria that the Cochrane process goes through when looking at diagnostic tests. And I would say that any of these, and business should be mindful that that's the process that needs to be followed. And in the end, a body like NICE will say, how will this land in the population? To whom are we applying it? Will it be valuable for individuals? The prediction for individuals is the key here, because we're moving from group findings where it might look good to individual findings in a particular setting. And a performance, I don't know, the story that I tell here is about the PSA, which you'll know about from prostate cancer screening. PSA on its own, the inventor of PSA says at one point was saying he wishes he had never discovered it because it had done so much harm. Because if you apply it indiscriminately in populations, what you do is end up operating on people who have benign prostate cancer that would never have killed them. And so you are doing them harm, and with all sorts of consequences. And we don't know what the consequences of screening for these kinds of things for dementia is. We don't know how good they are. We don't know how well they predict whether you get dementia at 70, 80, 90, by gender, by culture, or by ethnicity, and so on. So what we really need to do is think it through incredibly carefully before it is unleashed on people with advertising campaigns, because what's the benefit and what's the harm? So that's before even thinking about new parameters.
Thank you.
Thank you. We have got a question that's come up on the Q&A, and thank you very much, my colleague Li Fang, for doing that, because we'd like to encourage everybody to put their questions into the Q&A and not in the chat. So here's the question from Li Fang. Professor Brayne, what have been doing some of the key efforts made to enable a paradigm shift from the current focus on individualized approaches to population-based approaches in reducing risk for developing dementia? What is your evaluation of these efforts, and what should be the way forward in this regard?
Yeah, it's almost, it's like there's a very strong river flowing, I think, and we're trying to shift it slightly. So I think it's a pretty difficult thing to do, and I think it will take time. But if you look at from the G8, G7 discussions from the World Council on Dementia, it's always in there, but it isn't the dominant factor. And I think it's partly because it's difficult. It's also not great for life science. It's not the greatest message for life sciences, because it is saying, look, we need to do this. I mean, what I'm saying is trying to balance things up, because I think the emphasis is too much into the secondary or the screening type prevention area, rather than thinking about the mitigation and the true population prevention. So, I mean, I think you can see it in WHO, in G7 on a continuous basis on the World Dementia Council, and it's very hard. I mean, it's classic public health, where we know a lot of things that can be done in populations, whole populations, to improve health, but it's very hard to achieve them. So it's a question of developing policies that work for politicians of whatever color, or whatever type of government one has, and saying, actually, this is a benefit for everyone, and in the end, it will benefit business as well. It'll benefit the economy. It'll benefit everything. So it's kind of population health. If we invest in population health across the life course, it will pay off in terms of the economy. And so we have to try to work out what is, in an evidenced way, the sweet spots between what we understand about population health across the life course, including brain health at end of life, and economies, and also, of course, sustainability. And I think COVID is possibly a kind of point at which we might be able to get the wedge in to help do that.
Thank you again. Well, we've come to an hour and a half of your time, and I would like to complete today's session by inviting you to participate. I know you're a busy person, in as many of our discussions next week as you can, because your insights, I believe, would be absolutely invaluable, as well as your questions. And so we look forward to seeing you again next week, but of course, understanding that you have many competing interests. And I would also like to point out to all of the audience that there will be next Tuesday more and more opportunities for you to come in and discuss these issues about intervention and prevention of dementia in the Greater Bay Area. So we'll have several sessions that I would like you to take a look at on our website. We have a Twitter handle, we have an Instagram account, we have Facebook, and also a LinkedIn profile. So please feel free to send in your questions at any point in the next 10 days, and we'll do our best to try to address those. And finally, I would like to acknowledge the support of the Research Grants Council Hong Kong, and also the University of Hong Kong, and particularly the Faculty of Education, who has made it possible to give us this platform to do this work, and to make sure that we represent the interests of Hong Kong in the Greater Bay Area, particularly insofar as education as a virtue, as we'd like to call it in Hong Kong, and as a reserve may well lead to some protection against dementia. So I think you've made that point, Professor Brayne, very nicely. And I think we will return to that point next week. And I would look forward to any further discussion that we might have offline and online. And as a very final point, say thank you so much and congratulate you for carrying on the legacy of your great uncle, or is it great uncle? I would just point out that,
grandfather in terms of public health. Yeah.
Right. I would just like to point out that it's 110 years ago that the University of Hong Kong was founded by that gentleman, and you have more than completed the circle by showing us in a way how to lead forward in the next generation, the next century, in the prevention of what is a critical public health issue for particularly the Greater Bay Area, but China more generally. So please join me in thanking Professor Brayne for her incredible presentation today. It will be made available and recorded online, and this will be already obvious to you if you're watching this after the event. But I'm very happy to say that Professor Brayne has agreed to let us upload her presentation, and we hope to have it available to as many people as possible, so do spread the word. So once again, thank you so much, Carol, and we look forward to meeting you in better times.
Thank you so much.
That would be lovely. Thank you.